So that's a lot of what. I want to talk about why. I really want to get into this. I've mentioned it makes me blue, and it makes me angry at the same time. So let's try a different argument for why you should do code coverage. Let's pick some numbers for argument's sake. Let's say your app's 10,000 lines of code, because that's a nice number to do math with. And let's say you're trying to do 60%. And we've already established in the room 60% for a lot of people would be a new high water mark, shall we say. Okay, we've already established that. Now, if we put that in a graph, start with a pie chart. If 60% of your codes cover it, that's still a huge chunk that has no code coverage. That's 40% of the code that's got no tests. Now, those of you who do tests, if you were to just take 60% of your code and test it, you're going to find a lot of bugs, aren't you? That's why we write tests. We find bugs, it fixes bugs, and it makes sure they stay fixed. You all agree with that? Yeah, if you've got a target of 60%, you're going to be finding a lot of bugs in that 60%. That's what tests are for. Yeah. So let's say we found 120 tests in the code we're covering. And because we're not covering the rest of the code, we found no defects on the right-hand side, okay? Those are our metrics. 120 bugs found in that 60% of the code. And nothing found over here. What do you think you're going to find over there? If you were to extend it from 60 to 100, what would that look like? Why would it be any different? Why would the defect rate be any different? Why is that 40% going to be magical and have no bugs if you found bugs in that 60%? Why would it be different? It's not going to be, is it? Does anyone think the defect rate would be radically different?
Might be worse.
Might be worse.
Usually what might be better.
Usually worse, not better. Why do you think it might be worse?
The stuff that gets untested is more difficult to test.
Okay, that's a very good point. The stuff that goes untested is more difficult to test. More complex. Very good points. Does anyone disagree with that? No?
In general, I'd say that was true. You could also say the other way, that people will maybe test the more traveled paths.
More travel paths.
So yes, there are bugs, but they're bugs that would be, in code that would be executed less regularly. I'm not excusing that. I'm just saying.
Yeah.
I have a slide for that in a moment. Don't worry. You've raised a very good point. You've raised a very good point. I've got some slides for that in a moment. But let's assume the defect rate is roughly the same, because chances are it's not going to be any better. So if we put that side by side, hopefully visually you can see that's still a huge chunk of bugs waiting to be found. If you're finding 120 bugs in 60% of code, for argument's sake, that's still 80 more bugs waiting to be found, as a rough rule of thumb. But it's not just about the defect rate, the amount of bugs, because some bugs have a small impact on your code, some are catastrophic. And the reason for that, and we're coming on to your point now, sir, how many of you know what the term happy path programming means? I know you did too. You've had to sleep through these slides before. Okay, so for everybody else, happy path looks like this. You're taking your code, you're making sure the method works, produces the right output, calls the next method, chains on and so forth, so your app as a whole returns the right response to the right input. That's the happy path. Now the problem with the happy path is it's only dealing with correctness when you give it the right input. That's why it's called the happy path. If you give the API call, let's say you're writing an API server, okay? And whoever's calling the API, if they send what they're supposed to send, the happy path means that you'll return what you're supposed to return. And that's what most developers do these days. But this is an application without robustness. And you can change an app for, this is a world without robustness. An earlier draft of these slides said it was a fantasy without robustness. It's not the real world. The real world, people send us garbage because we don't control all the inputs to our apps. Now, all the unit testing most people do are finding bugs in that happy path. where a correct input isn't producing the correct output, and they're fixing those bugs. And those are correctness bugs. And when you find and fix all of those, your happy path works. Everybody's happy. And it might even look like your code's got 100% code coverage. It can look like that. I was very tempted to go through several well-known PHP libraries that are full of happy path and actually add code coverage metrics to them and show the difference between what they think they're shipping and what they're actually shipping. But that didn't seem very fair because they're not here to defend themselves. So I'm going to have to stick with talking in the abstract. But there's lots of code that's rarely executed. And a lot of that code is to deal with robustness. Not all of it. Some of it is to deal with genuine inputs that are quite rare. But a lot of the extra code that deviates from the happy path is to do with dealing with things that go wrong. We take our happy path, and we may have some garbage been sent in. Someone may have not sent some JSON they're supposed to, so we've got to deal with that. Or maybe the JSON's missing some fields, so we've got to deal with that. Or maybe the contents of the JSON field are not the right format or the wrong type, so we've got to deal with that. And we've got to add all this robustness code because our happy path can't continue at that point. We can't propagate bad data throughout our app. Now, what happens in happy path programming is they try to until the app crashes. But we can't do that if we want apps to work in the real world. So robustness turns working code into real world code. That's what it does. And I've done a very, very long talk on robustness at Edinburgh last month. And I'll be putting that video up at the same time I put this one up. They're going to be edited together. And I'm going to break that up into sections to guide people through, so you don't have to sit through it all in one go. Why am I mentioning robustness and all these rarely executed code? Because there's two things people don't test. And there's two things people say, oh, I don't need to test this. And the first one is trivial methods. One-line getters and setters are one people always say. And I had that on Twitter this morning. I've no time for that. I've done that. I've shipped code with a one-line method that had a typo in it. It set the wrong method, or it did a getter against the, sorry, it set the wrong property on the class because there was a typo. I've done that. You can't rely on IDEs and things saving you from this all the time. They are still quite limited in the analysis they can do today compared to where they're going to get to, and they're going to be awesome on this. But you can't rely on that. Your tests are meant to catch that. So that's all I'm going to say on that topic. But the other things people don't test is robustness code. It's hard to test. It's rarely executed under the conditions the developer runs it under, because the developer knows what's supposed to come into the app. So they rarely send garbage in when they're doing their own testing. It's one of the reasons why people recommended in the old days that someone else tested your code. Times have changed and that practice has fallen by the wayside, but we used to do that.
I always thought robustness was the things it should test. It's not going to be tested by a person.
For sake of brevity, I'm going to direct you to my Edinburgh talk once it's online. It's got a full, we go into robustness. It's 2 hours, 20 minutes long. And we go into robustness, what I treat as robustness in great detail there. So I'm going to direct you to that first. And you're welcome to come back to me and we'll have a discussion if you disagree with that. All right? Thank you. But this robustness code, what happens if the robustness code's got bugs? How many of you have shipped the robustness code that's gone pear-shaped on production? I've done it. Yep. And what's happened? How would you characterize it? It makes a bad situation worse, doesn't it? When robustness code goes wrong, because it's already dealing with a failure. Something's already going wrong. And if your robustness code has bugs and doesn't handle it properly, it often creates more of a mess that someone's got to go and clean up. And this has an impact. Remember these people? These are the people it's all about. How many people work in firms that deal with customers? Yep. If these people are unhappy, who feels the pain? Do you feel the pain? Does your manager feel the pain? There's a saying about the brown stuff, it only flows one way, and that's downhill. Yep, most of you must have heard that. But when you do this, you hurt your organisation. You hurt the reputation, and we see today in tech, reputation doesn't matter until it gets so outrageous that people are forced to act from outside pressure. We see that all the time. We see it with Silicon Valley. We see it over here with UK firms as well. But there's another thing, and this is where I'm going with this. Have you ever thought of the cost of dealing with a failure? How many of you have to manage budgets at all, or manage team schedules or project schedules of any kind? A couple of you. I do that. Yep. So there's a rule of thumb. If a defect gets past one stage of your project to the next, the costs of fixing it go up by a factor of 10. That's a rule of thumb. You won't find online a source paper capturing that and proving that one way or the other. If you go onto the Wikipedia page for all of this, you'll see that on there, one of the main criticisms of this, that is a number that's been taught for decades. Nobody has hard data to prove it. Okay?
It feels right.
It can do. I think it varies from organisation to organisation. But if we run with that for now, because that's what people are taught, it's what I was taught when I graduated, that's what it looks like. If we plot that on a graph and we multiply each cost by a factor of 10, and you see how when a bug gets to live, it's really, really sodding expensive. Yeah? Now when you see it like that, it does look a bit egregious and a bit extreme, doesn't it? Because if everyone was working in organisations where bugs in production cost that much, they'd be going bust. No one could absorb that level of screw-up costs all the time. So let's ratchet it down a bit. But even if you just do it as a factor of 3, and I've got a memory that the Wikipedia page mentions a firm who said that their internal figure was something like 3.4 times. But you'd have to check the Wikipedia page to be sure. Even at 3 times cost, you still get this. That still looks horrible. Just look at all that waste. This is a graph of waste. That's what it is. It's waste. And let's plot it as an area instead. Some people might find that easier. Some people might find that easier to visualize. Just all this yellow area is waste. Why does it cost so much when it goes wrong? Those of you who are used to cleaning up bugs that have snuck through, where's those costs in your organisations? Anybody? Please.
I mean, part of it is accounting for the behaviour that does happen while there's the buggy behaviour.
Yep.
And cleaning up after that, advising people, saying what will happen when it's fixed, blah, blah, blah.
Okay.
That's part of it.
So there's some cleanup to be done.
Yeah.
There's some communication to be done.
Yeah.
And who are you talking to? Internal or external or both?
Like the internal and
Internal and external.
with the customer in a way which kind of informs them what the effect on their customers is like.
And are you doing all of that communication, or are you passing messages on to other people who then do some of that communication as well?
Well, there's going to be a chain of communication.
There's a chain of communication, right.
I mean, whether or not it's one person speaking directly to people, there's going to be a bunch of people involved, and you can have nexus.
So more people are being brought into the cleanup operation than just you yourself. Yeah. And does that sound typical for everybody else who's involved in the cleanup? It's not. I'm not saying it's your code that's gotten wrong, but when you're the developer looking at how to solve the situation, you're never on your own, are you? There's always other people involved. But we can break that argument down that you've just given into 3 things. In order to fix the bug, you've got to change your application. And sometimes you can get lucky. Sometimes it's a 1-character or 1-line fix. That happens quite a lot, thankfully. But sometimes your app's actually gone down a dead end, or a little bit of a dead end, and you've actually got to walk some of it back. And it's not just the broken functionality you've got to fix. There may be some functionality that currently works that your bug then breaks. And if you haven't got tests and code coverage, who finds out? Your customers, and then you're back in the cycle all over again. I've worked in firms that did that. I don't work there anymore. So you've got, that's a big cost. You've got to put things right for the customer. We talked about needing to talk to them. I've worked in businesses with hundreds, if not thousands of customers, business to business. And what they do is the customers go, well, you've not met your contract for the month. I want a discount. I don't want to pay for next month's service, or I want a refund, or I'm going to take my business elsewhere. You're starting to accrue costs there as well. How many of you are familiar with the phrase opportunity costs? Oh, that's good. So for everybody else, an opportunity cost is when you should be working on A and you can't, and you're missing out on that opportunity and the extra revenue that it would generate for you. Would you say that was fair? Okay, thank you. And this is something a lot of management teams don't realise. They'll look at the amount of people being brought in to do something, but they don't think about what those people should be doing. And you may be pulling people off R&D, or you may be pulling off people signing another contract or doing pre-sales, depending on how big or small your firm is. But you're taking people away from their job in order to fix something that was supposed to work first time round. And where does that money come from? All of this ultimately, unfortunately, has to turn into money if you're working in a commercial organisation. Because money, unfortunately, is ultimately the blood that keeps the organisation alive. So where does that money come from? Have you ever thought about that? When the cleanup's being done and 4 or 5 people are there, you're working late at night, who's paying for all of that? What, And the answer to that is people fall back on this. Have you seen this before? It's sometimes known as the iron triangle. Although I know the iron triangle is slightly different things. You can pick 2 of these. You can pick fast and good, good and cheap, or fast and cheap, but you can't have all 3. Yeah? And that's ultimately where the costs go. The costs go in sacrificing the quality of the product, what you're able to develop, your roadmap going forward, costs you in people, costs you in time, costs you in reputation. And you end up having to decide as an organisation, or you end up sleepwalking into it, which is what a lot of organisations do, you end up sleepwalking into somewhere on this graph. If you're not managing these costs, and these costs are getting bad. And this is something that really gets my goat, because I know this is bullshit. It really is. This is the graph of a failing organisation. If they can plot on here, they're a failing organisation. And it really gets my goat, because I've worked in too many of them over the years. It's not nice to work in. It doesn't have to be like this. This is a failing industry. This is an industry shipping garbage. We don't have to. We can do better than that. And what comes out of that? How many of you have heard of 10 times programmers? Yeah. The idea that some programmers are 10 times more productive than the average. And you've probably seen them called unicorns and less flattering things online. You've probably seen that. There's a lot of people skeptical about them. They're real. They exist. I've worked with them. And do you know what? When you look at these costs, all you've got to do is stop causing these costs. It's all you've got to do to be a 10 times programmer. It's all you've got to do. Ship quickly, but avoid the costs of shipping. Avoid shipping garbage. Ship code that sticks. Because then you're not incurring these costs here. And to do that, you start with habits. You start by trying to be excellent all the time. Which is where I have a lot of arguments with a lot of people. I do apologise. But it's not optional. It's not something you do when you feel like it. It's not something you do on you go, oh, this project can be excellent, this project, so it doesn't matter. You practice it over and over and over until you can do practices that allow you to ship code that sticks as fast as people who aren't doing those practices. At first you go slower, but eventually it gets there. The idea is to ship code that you write, that's right first time, rather than code that needs to be rewritten next time. Very important with that. When I first came into industry, we had a phrase, fitness for purpose. It's not about over-engineering, because you can spend an infinite amount of time on code quality, but there's diminishing laws of returns. It's about learning that point where you've got all the coverage, the tests are sensible, and you can ship it, and it's not going to break. It's not about saying, oh, I've got tests, I've got 100% code coverage, but I don't know what it means. I don't know whether the tests are any good. It's not about ticking a box. It's about work, not rework. One of the things you'll see if you ever get to follow these type of programmers around is they're constantly asking questions. They ask the business to the point of insanity. What do you want? Why do you want it? Is that really what you want? They'll go away, they'll take it apart. They're not just programmers, they're also doing the business analyst work. They're working out, does this make sense? Is this actually a problem we're shipping rather than a solution? They ask all those sort of questions. People who don't ask questions ship code that needs reworking. And what they're trying to do is break this. You can't see it very well. That's actually Darth Vader that this stormtroopers are looking at. Hear no evil, see no evil, hear no evil, speak no evil. You get a lot of developers who go, don't care, don't want to know, just tell me what to write, I'm going to write it, and that's all I'm interested in. They don't, some of them are doing it deliberately, but most of them don't know they're ignorant. Chap in Bristol, Kelvin, he does books for O'Reilly, and this is something he talks about in his talks, about knowing that you're ignorant so you can start to switch to an evidence-based approach, starting to pull data in, such as code coverage, in order to start making better decisions. Because we're supposed to be professionals. This is supposed to be a profession. How many of you know there's actually a chartered institute for software in the UK? Yep. The BCS. Or their new title, it's not that new I guess, Chartered Institute for, I should know it. I've done their website in the past, I've done some of their internal systems in the past. But that is them being on the path to being the equivalent of the General Medical Council for software, because that is what the BCS was set up to do and has been their stated aim since the 80s for certain. And then they realised they could make money doing the computer driving tests and that sort of thing, which helps fund their work, which is excellent. But there's a group of us who want this to be a profession, like doctors, like lawyers, like teachers. Yes, please.
How near are we to taking both?
I would say we're further away than ever. There are days I think we need the equivalent of a GMC, but there are many, many days when I think it would not work. And the days where I think it wouldn't work outweigh the days where I think we need it. But then I'll be pulled into a piece of code, often a piece of open source, famous open source that you will all have used, but I'm not naming names, and I go, I wish there was someone here who would enforce professional standards so that this kind of thing never shipped. There are days I have those. I don't know how many of you are aware that all those regulated industries, it's not just their output that's regulated, it's their conduct, their day-to-day conduct. Their practices are regulated, both in work and out of work. I don't know if you realise that. It's a very different world. If you don't, go look up about what it's like to be a doctor, what it's like to be a lawyer, what it's like to be a teacher. Teachers are probably the easiest to find information on. It's a very different world. But these standards are there because these are old industries that have been where we have. And at the time in society, it was felt that we can't live like that anymore. Now software has exploded and it's got massively ahead of the curve. One day software is going to stagnate and then they'll start to reel us in again. We're supposed to be professionals, let's get these practices in place. Which is where the title comes from for this talk. Be professional or leave the work to the professionals. That is the nub of my rant. Any questions? What do you all feel? Please.
So, code coverage for unit tests and maybe integration tests, things that are run under, say, XDebug. Yeah. It's quite easy to get a metric for that. You get 100% or any whatever number. Yeah. Testing behaviors. Is there any similar way you can get? It's quite easy to have a bunch of them that will happen in production that you need to think of up front.
This is where you need humans, and code reviews are the best thing for this at the minute. There's been a lot of research around testing and QA teams and whether you even need a QA team. And some of that research has, the results of that suggested that code reviews are actually better than having a QA team. That having developers who can read the code, who can understand the consequences of that code and are willing to follow it through and ask questions will find more bugs than people who haven't got a clue what they're looking at. Because of course test teams are deliberately black box testing because they're trying to come up with all the things other people haven't thought of, which is why they're black box. And there's some research that suggests that actually code reviews produce the best results. Yes, please.
Okay, so some of the argument that you're making seems to be about, I mean, it's thoroughly uncontroversial. More things should be under test. You should be able to verify things. You should act professionally. I mean, I would doubt anyone in this room disagree with that notion. I think it's really just the nature of 100% code coverage and the fact that it's just an impossible thing. So if you're a web developer and you're outputting things to a web page and you've got a modern app where tons of things are happening inside the browser and interacting, it seems to me that it's more important to have an overarching sensibility of what will reach that quality level and to ensure that you have the right sets of feedback loops. And that includes unit tests, it includes functional tests, it includes the humans that interact with it, and it even includes stuff coming in from production. So long as those things are in place, then you can keep up that reasonable level of quality without pursuing this arbitrary metric that isn't 100% of the things that could possibly be tested. So it's not really an argument against what you're saying, because I entirely agree. I think that the proposition is confrontational intentionally, but I think that it would be confronting people who think it's okay to not be professional. And I certainly don't consider myself as one of those people, and I imagine that most people here wouldn't either. I don't know. I mean, I don't know if you've done this to other people, if you had like different kinds.
This is the only time this talk will be presented. I have had these arguments when I've been pulled into other projects with people. You are the first one to raise about the limitations of coverage. Now I believe, I'm not a front-end developer, so I only read about this stuff, I don't practice it, so my knowledge may be incomplete, it may be wrong, but I believe Chrome will allow you to do test coverage in the browser. So the code you download to the browser, I believe you can get test coverage out of the latest versions.
There are tons of tools. The devs tools are obviously very, very sort of complete, but all these different systems interact with each other in ways that are very hard to necessarily second guess and describe. A lot of them can be subjective. A lot of them can be only measured really by the human eye.
I disagree. Let's work this through as a thought exercise, if you don't mind. So let's take a web app with a mixture of HTML and JavaScript front end. Say something using jQuery for argument's sake, rather than like a single page app. The backend API is written in PHP because that's what we all know. It's talking to a traditional database server. Okay. So, and obviously all of this is running on a set of operating systems. You've got the desktop operating system. And you've got the web browser the user has chosen, which is hosting the code that's on the desktop operating system. You've got whatever you're running your PHP code on. Hopefully it's a Linux distribution up in the cloud, but it may not be. It may be Windows on Azure or your own hosted. It's using a database server, most likely MySQL. If you're on Amazon, you could be using their RDS engines of various types. Some of you may be using Postgres. Some of you may be using Mongo. Those are popular choices. And again, those are running on servers that have operating systems. They may be running inside virtualization. Some of that code may be running in Docker and containers. So there are a lot of moving parts. They're all glued together by networks, which is a mixture of software and hardware, and cables as well. Lots of things that can go wrong. But the behaviors of all of these are not that complicated. A lot of these things, so we've got this base layer of hardware, and we've got a lot of the hardware is well tested, well understood. Apart from Intel, who shipped a web server inside their chipset that you can access and take over a whole box with. I don't know if you guys know that. You not heard that one? Yep. So hardware I mention that because hardware can produce surprises, and hardware surprises are often impossible to deal with because your code never sees whatever the surprise is until it's too late. Like that web server, for example, it is intercepting packets off the network card before the operating system sees it. So you can't put a firewall in place to stop the packets on the machine. If someone can send a packet to that machine, they can take that machine over. Okay? But in general, the hardware is well understood and its properties are well understood well enough that it's going to be reliable. Okay? And the hardware will fail in known ways. Yeah, you'll have a hard drive failure. You'll see that as a start to have corrupt file systems. RAM failure, you'll start to see corrupt data. And hopefully, if you're running on servers, that will be reported to the operating system before your app starts to see corrupt data, hopefully. But these are all known failure patterns, some of which we need to contend with our code and some which are handled for us. Because we're running on code that has already been tested by other people. We're not running on huge amounts of untested code. Fingers crossed. Can't always be right about that. And it's the same with each of these building blocks. We're not always building on sand. Sometimes we are. If you've reached out for the very latest NoSQL type database of some kind, somebody who's trying to take down Mongo, for example, sometimes that stuff's very experimental, has very bad testing, or very embryonic testing because they haven't been able to invest in that because they're investing all their money in just trying to get market share in order to take on Mongo, for argument's sake. Seems to be the current game. But in general, you're actually picking technologies that are relatively reliable. And you're also interacting with them in very limited ways. If you're talking to a database, you're making a database connection, you're sending an SQL request or a NoSQL request of some kind, and you're getting a result set back. And that's something you can test for. If you get the wrong result set back, your correctness test will pick that up because they're not getting the data back out to the end user that's expected. So your correctness test, your happy path, should already be picking that up. If they start sending garbage back, that's where the robustness type testing would come in. And there's only so many ways you need to account for in order to say, well, what's going to fail? Because you'll see the symptoms. A lot of the failures will generate symptoms that are similar enough that you'll catch them with the same type of robustness code.
Yeah, I mean, I would agree. As long as you take care of those things, it is possible to achieve a decent level of quality for those reasons that you've given. Yeah.
But I don't think, with practice, I don't think it's that hard to do. It takes practice and it takes experience, often bitter, hard-won experience of, I mean, how many of you have regression test suites? Yeah. So these are tests where you've written up things that have gone wrong and put them into your tests so you make sure they stay fixed. Very handy. Yeah. That's part of increasing the coverage of behaviors. Because you rightly say, no one can anticipate everything. But we can anticipate a lot, and with experience we can anticipate the things that matter, the things that will happen, and then when we are surprised, we've got this test suite where we can plug in that extra knowledge and we can build that knowledge. So it's not in here, it's not even in there, it's available for everybody. And that's my counter argument. But it does take time, it takes investment, and it takes practice. And if you do it with practice, it's quick and easy.
I don't think it's a counter argument because I do agree with you.
But if anybody else was, your original argument, if anyone else was supporting that incompleteness, I would say the counter argument is there's only so many things you need to worry about. You learn those through experience.
But I think at some point in the talk you did even say that. You said that the target isn't quite 100%. So there is a...
I'm just going to pull that up.
Yeah. But there is a critical mass of quality, though.
There is a critical mass.
Yeah. Which I would certainly agree with. And if that constitutes 100%, which I'm not sure it does.
There we go. Well, there is another argument. No one can afford zero defect code?
Yeah, it's the diminishing returns thing, as you said as well. Yeah.
The costs for zero defect code are enormous. I have been on a project that had to ship zero defect code. And I go into that in more detail in the Edinburgh talk, which the video will be online for that. But in general, no organisation can afford it. Diminishing returns, as you quite rightly say. And eventually, at some point, you have to ship, because sometimes you've got external pressures that you have to hit. A lot of firms I work with, for example, their deadlines are contracts they've signed, but also they can be trade talks, trade shows, where if they don't have a product on that stand, that's it. They've missed their whole sales and marketing cycle for a quarter, sometimes a year. Not everything is done online on demand. So eventually you have to ship code, because if you don't ship code, what's the point of writing it? In a commercial organisation, you can have a lot of fun writing code just to explore ideas, but in a commercial organisation, you've got to ship. So I agree with that. Anybody else? Yes, please.
I think if more people practiced aiming for 100%, there would be less arguments about visual debt. My impression is that they don't care quite so much. So they sort of have the same standards. Like, yeah, you don't really need to type in there, it doesn't really matter all the time. The same way you wouldn't need to test all your code with DX.
So where they were coming from with that video was OOP and all the mechanisms of OOP, object-oriented programming. There's a lot that you've got to do all at once. It's quite a steep learning curve. Before you start learning frameworks, which are their own steep learning curve on top, just the actual mechanics of programming OOP is quite hard to learn. When I first learned OOP in '96, and I will quite happily say it took me 4 or 5 years before I was comfortable writing OOP code. Even today, even last year, I've been changing my OOP programming style. I'm still learning ways that I'm more comfortable with. It has a steep learning curve, and it's important to acknowledge that. And if you've got people coming into the industry, especially if they're not going through any form of formal training, they're teaching themselves, getting a job, learning on the job, which seems to be the majority these days. And it's not a criticism, it's an observation, that's the way of the world. All these things in the visual debt video look overwhelming. Hence the idea to take them out and reduce the cognitive workload. And I've got sympathy with that because I know how long it took me to learn OOP. At the same time, that message was incomplete because it wasn't saying you're going to come back to these later on when you realize why you've got to come back and add them in. That part of the message wasn't there. The video was presented, that I recall, more in a style of, you don't need these things ever, they're just in the way, get rid of them. That's how I remember that. That's how the message came across to me, and that's how I remember the video.
There was a good point that it was presented wrongly without context.
Yeah.
There should have been more subtext to it, like why they are important, but you maybe missed it.
Agreed. So that subtext was missing. And then in the discussions afterwards, we discovered that the author of that video, his peers, are taking those practices and using them on at least one open source project deliberately. In fact, their README actually says if you send us a pull request of any of these things in, we will reject your pull request. Now, I have not checked to see if it's sorry.
I thought that was the thing with the joke.
No. It's a joke until you start rejecting pull requests. At that point, why is it a joke? At that point, it's a practice.
It sounds like a religion. I mean,
well, I don't want to go that far.
yeah. Okay.
I think they see themselves as having some fun. I don't think they don't come across as having understood the impact of the message, or how people who aren't able to evaluate that message themselves, who are looking at this material because they need help and they don't understand what's going on, people will take it on board verbatim because they don't know any better. And I don't think they're understanding that. I mean, I'd been programming, probably 8 years before I used any sort of language that had any scoping of any kind. I'd been programming for 8 years before I needed that. Something like 8 years it would have been. It wasn't commercial programming, but it was projects that shipped and that people used. And I did that with no scoping at all. So, and I didn't know any better. I didn't know scoping existed. I mean, back then, hardware didn't even have memory protection. anything could write to anywhere, and it often did, which is why software crashed. So that's where people start from. So the rest of that message about this is only a starting point, you're going to need all this and we're going to show you why later. If that had been there, I think it would have been a lot less controversial.
It's kind of the same like trying to get good code coverage. Like take you a while to get anywhere near that, like starting out.
It does. But the people who I see online objecting about code coverage, they're not people at the beginning of their career. They are people who are my peers. They are people who get gigs at conferences. They are people who are out there, senior developers in their own teams, their own organizations, teaching people who are learning on the job. And they are objecting to 100% code coverage, which is why it gets my goat. It really does. If they were to say that subcontext of we're going to work towards it, we have to start somewhere and work towards it, we can't deliver it straight away, that's fair enough. But when I see people saying 100% code coverage, don't do it, it's a waste of time, waste of money, has no value whatsoever, that gets my goat. It really does. I think for all the reasons I've said, they're hurting their organization, they're hurting our profession.
Can I just make one class? One thing I've really taken from this, reports of code review. I really like the idea of code review as maybe the primary mechanism or maybe an extremely important mechanism for boosting that percentage. You said early on, experience organisations where tests work really well.
Yes.
I've also been in a lot of code reviews where people didn't really know why they were there and how they could contribute.
Okay.
So if that was kind of the number one objective of every code review, how can the test be improved? That would focus mine. You talked about the challenge of learning OOP principles. Right? A lot of testing principles are very subtle and take a long time to learn as well. So I'm really attracted by this, it's making code reviews the primary thing for it. And the last thing really is the code reviews are a great way of kind of communicating the culture of the company.
Yes.
It talks about culture and quality, or we suggested it. Again, I'm really thinking about that now, how we can make code reviews reflect the culture, enforce the culture.
I think those are all awesome points, especially the culture one. I agree with all the things about making sure people know why they're in code reviews rather than they're just there to make up numbers. On that point, I would refer you again to my PHP Cambridge talk, because when I came into the industry, I was taught a 3-step method for doing code reviews. It's a method, I don't always get to use it in every organisation, but when I can, I do introduce it because it's a method that has never let me down and has stood the test of time. As practices have changed, as code has changed, as the services we're delivering has changed and how we deliver them has changed, that 3-step method has survived in my experience. So I'd recommend that presentation to you. If you can't find it, ping me on Twitter or something and I'll dig the link out or send you the slides direct. But the point about using it to communicate culture, I think, is amazing. I think that's so good. I mean, what do you all think about that? How many of you have been in code reviews and gone, why? What's the point? It's just an interruption to the thing I want to be doing, which is writing code. Any of you had that experience? Yeah? Have you been in code reviews where the advice you're being given is contradictory depending on who's in the room? Who's doing the code review with you? That's a form of culture. Contradictory advice is a form of culture. Part of culture, part of establishing what your company is about and why your company is successful is systemizing, saying these are the things that are us, these are things that make us successful. Some of them are people and behavior, some of them are technical practices, and some of them cross those boundaries. If you put those in place, it's part of building a team. It's part of bringing everyone together. I think it's an excellent point. So this sounds like you're going to be going back and perhaps considering some changes, based on from our conversation before we started the talk.
We're at that happy time, and you're about to change our version. You're about to move from some version to Git, and everyone thinks it's going to solve their problems. But I see this as a great opportunity to a lot of code that we into our organisation. We're very good at sharing. We use Slack channels and people always putting their pen in. So it would be great if people could put their chain sets up there. Yeah. And QA by anyone who wants to take the interest. And I'm interested in kind of people sharing experience. Yeah. Improving practice. So I think it's a good time for us to try and use this.
Awesome. I think you'll find it easier because you're switching to Git. Obviously, you're going to have that learning curve of Git and the myriad of ways that you can get into trouble with Git.
Well, actually, now we've got a number of people who've used it before. I had to unlearn 5 years of Git to work to virtual. For example, today I got it wrong because I forgot that when you're in small subversion, you don't actually bring that history with you. So I've forgotten that much.
My opinion is Git is easy. It's easier to do code reviews with Git than with anything else at the minute, because it should be driving you down a workflow of some kind that's using branches for features, rather than everyone committing directly to trunk all the time. You may have people merging into trunk rather than into a separate branch. That's there are practices and arguments on both sides, but as long as you've got people developing in a branch, and then you can do a pull request or a merge request depending on what platform you're using to manage your Git repositories, I think you'll have an interesting time. And hopefully you'll continue to have a happy time.
We'll see.
So this is something else I'm going to look forward to hearing from you, how it went, to add to everything else we've talked about. This is why I do it. This is why I come up and do these talks, because people go away, they try things out, and they change their organizations, they change their culture, and hopefully it solves problems. It may reveal new ones. It may reveal limitations in the advice I'm giving, the experience I'm sharing. But if you go away and only one of you changes something tomorrow or Monday, and that change sticks, it was worthwhile for me. It really was. So, anything else anyone wants to talk about or ask about before we wrap this up? No? Well, thank you all very much for your contributions. You've been a great audience. I'm available on Twitter. Any follow-up questions, just send them out. Slides are already up on SpeakerDeck, so I'll send a link out to those tonight. And the video, I won't be editing that for a week or so, mostly because the laptop's run out of disk space. I've got to clean up the laptop first before I can edit both videos. But the videos, I'm aiming to have them both up by the end of July. Thank you very much.